so it's good that I came. So more people will know about Mellanox. So Mellanox Technologies, for whom that raised his hands, may be familiar with this company from the HPC market. We're very famous there in technology called InfiniBand. The big HPC customers like us very much because we are basically providing for almost 10 years in the InfiniBand industry. The power of InfiniBand means lower latency, high bandwidth, no comparison when it comes to the network operation. It must be top edge, right? So what we did basically, we took all those advantages and brought them, I think, in the last 5 years into the Ethernet market. So this is our biggest advantage over other vendors. We are basically using our silicon, and we're offering those advantages on the Ethernet market. So today we are going to focus on the overlay solution as I said, in the OpenStack context. Let's go and do some evolution of what happened with layer 2 fabrics. So people love layer 2, especially the server guys, right? The network guys, yeah, most of them are. But layer 2 is a pretty basic concept. You have a VLAN, you are connected to the network, you have what you need, everything is fun. At the beginning, there were some STP-based tiered solution. That's not a very good solution because basically you're losing a lot of links and you're losing a lot of bandwidth. You are paying a lot on the equipment, but not utilizing all the network that you need. It's a full layer 2 solution, but again, you're losing a lot. So this is this solution. It was a way ago. Again, using 2 chassis connected through a VPC or MLAG or any other solution was the kind of a next generation where by this proprietary solution, you utilize all the links that you have using layer 2 from top of rack to the spine, using 2 chassis, and this was the solution. But the problem with this solution is, first of all, it's a proprietary solution. Second of all, it doesn't scale. Okay, so you can put 2 chassis. It's a kind of, let's say, can be a dangerous thing. You can lose a chassis. You are paying a lot in phase 1, right? You're not paying as you're growing. You're putting the investment on the chassis on phase 1, using a proprietary solution, and it doesn't scale. But still, it's layer 2. And the new and improved solution today is the overlay solution. It's basically the network virtualization, where you are getting the advantages of using layer 3, which is considered still maybe in many network people as a complex solution. But on top of the layer 3, you're offering an overlay solution, which is basically layer 2. And most of the times, this is being used by VXLANs. So what are the advantages there? You're using layer 3. It means that you don't have any limitation when it comes to scale. You can use what we call scale out or pay as you grow or web scale. There are many terms for that, but basically it means that you are putting your rack, you're putting your top of racks, you need more power, compute power or storage, you're putting another rack with another top of rack, you need to connect the 2 racks, you're putting a spine. Okay, you want to grow further than that, more racks, more spines. And you are scanning as you are scanning layer 3, while basically offering the service to the server people by layer 2. And the way that it works, that you have your underlay, which is the layer 3 configuration. We'll go over that in a minute. And on top of that, you are running a VXLAN packets. Now, those VXLAN packets needs to terminate somewhere, okay? Because at the end of the day, let's say you have a VM, you have a VLAN there, right? You need to actually run with VLAN. So you have 2 options. In a virtualized environment, you can do it actually on the hypervisor. So your hypervisor can do this termination when a packet or a beginning of the packet means in the terms, the technological terms, it calls encapsulation and decapsulation of a packet, right? So you're starting as a VLAN. You want to go out to this layer 3 network. You need to encapsulate this packet, the Ethernet packet, make it a VXLAN packet. The packet is going somewhere, somehow. We'll talk about that through tunnels. All over the layer 3 network, and then it comes back to the server, and it needs to be decapsulated, right, and get back to be a simple VLAN. If you have a virtual environment, if you are running Neutron, OpenStack, Neutron can control that. It's using something that is called ML2 mechanism drivers to do that, and you can do the encap decap on the hypervisor. But sometimes you have bare metal there, and bare metal doesn't know how to do those things. So what you need to do there is have this NCAP DCAP capability on the top of rack. This NCAP DCAP capability is called basically VTAP. Okay, so we're going to use this term in a minute and during this presentation. So we basically describe two options. One of them to do VTAP on the hypervisor. The second one is to do on the top of rack. And there are also two options how to control this. So one of them is with a controller. So you can use Neutron for that. I think there was a big progress made to make Neutron more scalable for this operation. But we have a lot of customers that are actually using other controllers. Some of them, you know the names. For example, Nuage, Midonet of Midakura. In other industries, it's NSX from Weaver and so on. And this is the controller-based solution. And there is another way that is called controller-less, which is basically EVPN, which is a BGP protocol, doing the control over a BGP protocol. Okay, and we'll discuss this option also, and this is a controller-less option. So we talked about doing this termination, this VTAP, on two places. One of them is on the server, the other one is on the top of rack. This is the Mellanox portfolio. How does it relate to that? So this is a good chance for me to say that we are, and people may not know that, we are actually the only company in the world that is doing end-to-end networking. What does it mean? It means that we are doing from PCI to PCI, the NIC cards, the cables, switch, cable, NIC card. We are producing everything ourselves. We are designing everything ourselves. Every component inside the system is ours. For example, on the NIC, we're doing the silicon, the drivers, of course. On the switch, we're doing the silicon inside. It's called Spectrum Silicon. The system is called also Spectrum. The system itself, we're not using ODMs, and the software on top. So we're running Mellanox OS, which is our own OS, and we talk a bit about it later. We're doing also other operating systems. For example, Cumulus can run over our switches. So we're doing end-to-end, so why should you care about that? So we don't have to buy everything from Mellanox. By the way, you can match whatever vendors you want. We are totally open. We are not locking anything. You can use our switches with our NICs or our NICs with our switches. Actually, I think 80% of our deployments are like that. There is always something around there. Most of the time it's Cisco. Well, they were here for a long time, so we must be interoperability, with other vendors, and we're making sure that we are doing that, okay? So again, why should you care about the fact that we are end-to-end company? It means that we have a unique vision that other vendors does not have about the purpose of each of those components. For example, we think that all the offloads and acceleration should happen on the NIC side. And in this session, because we are talking about overlay, I will talk about specific offloads that are related to overlay, but there are also others, okay? Here's another fact about VXLAN that I would like to emphasize here in this session. A VXLAN packet is a UDP packet. Okay, it's basically, as I said, it's an Ethernet packet encapsulated inside the UDP packet with additional headers. If you're using a traditional NIC, it means that if you are doing this VTAP operation, the traditional NIC actually doesn't know what it is, what this creature is. Okay, it doesn't used to deal with those things. It's used to deal with the traditional packet, right? It's going to the VLAN header, it's doing checksums, it's doing RSS, TSS, basic stuff that are being done by a VLAN. So if the NIC doesn't know what to do with the packet, what exactly it's doing with it is just pushing it up to the stack. Now here is a thumb rule. We are in Mellanox doing 1, 10, 25, 40, 50, 100 gigabit Ethernet. Believe me, if you will net software do network operations, you will not achieve much bandwidth in your network. Okay, the performance will go down because once you're involving software in network operation, it cannot work. There is a way to make it work. It means basically to put more CPU resources on the network operation. And this is exactly what in Mellanox we think should not be done because we think the CPU should be handling the application, not the network. So in this example, what we did is offered a VXLAN offload. It basically means that the basic stuff that a NIC is doing with a VLAN, our NIC card, ConnectX 4 or 5, which is, as I said, from 10 to 100 gigabit NIC card, is doing with a VXLAN. The basic RSS, TSS, checksum operations. And you see in a benchmark that was done with connected 3, which is quite an old NIC. So the same results, believe me, I don't have the updated slide. It's happening with 100 gigabit with connected 4 and 5. You can see that on the left, this is a plain VLAN, okay? And you see here it's 40 gig, we are reaching full line rate almost, 37.5. If you are running VXLAN with no offload, it means that the hypervisor is doing the VXLAN operations, then you are reduced very much on the bandwidth, okay? Bandwidth is very reduced. And look what's happening to the CPU. Because the CPU now needs to handle this network operation, is getting up when the CPU utilization. Now, if you are using the VXLAN offload, then you are reaching almost the same numbers as a VLAN when it comes to VXLAN. A simple thing, if the hardware can do it, it doesn't make any difference if it's VXLAN or VLAN, the same thing happens. And the CPU, again, is reducing to its normal values. So this is called VXLAN offload, and now you may ask yourself, okay, this is a very fancy feature, how can I get it? So this is the magic of our feature. All our offloads, by the way, and accelerations that we are providing on our NIC cards, they are coming for free. It means that basically it's coming inbox in all the projects of OpenStack. Specifically for the VXLAN offload, you need to actually open a flag in our driver, and you have a community that can do it. There are other features that we are offering as offloads, for example, RDMA, SRAOV, and others. ICER, which is iSCSI over RDMA. I'm throwing a lot of words here. It's a different discussion, but all of those are existing from, I think, Havana, something like that, inbox. Okay, so basically when you are plugging our hardware, you are getting it. You don't need to do something special. All the application APIs remains the same, and you are just getting the performance benefit. So this was about the NIC side, VXLAN offload. Another offload that we are offering is the OVS offload, or in the marketing name is called ASAP Square. So in a nutshell, I will not go deep dive into the details. I would say that OVS has a big part in the cloud infrastructure. Specifically is doing also the NCAP, DCAP operations. So what we're doing, we're offering two options basically. Something is called ASAP Square Direct, where basically we are removing the OVS as it is from the flow of the network. Now packets will go directly from the application through the NIC and to the other side, meaning that if you want to copy memory from one machine to another, you're using a technology called RoCE or RDMA, where the application is connected directly to the NIC and moving the packets from one side to another. And when you are doing that and you are removing the hypervisor from the story, then you need something on the NIC to be able to do some operations that the OVS is doing. And this is exactly what OVS offload is doing. Basically, we're bringing down some of the OVS operations into the E-switch. We also have an option that is called Flex, which is more, let's say more common for our customers, because the Flex is basically saying we cannot cover all the functionality that OVS has on our NIC. It cannot happen. So what we are doing, basically, we're putting there some OVS operations, and what can be done by E-switch will be done by E-switch, and what cannot be done by E-switch will remain in the OVS DB. So from the customer perspective, from designing your cloud, you're basically just gaining from it. Okay? Everything that can be done by hardware will be done by hardware, especially NCAP, DCAP, which is heavy operation, and other policy rules will still run on the hypervisor. So this was another offload on the NIC side related to VXLAN and overlay. Now, what about the switch? What is the purpose of the switch in this flow? So as I said, first of all, sometimes we need to do the VTAP on the top of rack. This is available on all our switch products. Beside of that, in general, and not related to overlay, our switch products all are running on top. Basically inside there is a silicon called Spectrum. This is our silicon, our new most advanced silicon today. We also have Spectrum 2 coming next year with 400 gigabit Ethernet. I know it sounds kind of, yeah. But this one is doing up to 100 gigabit. In our leaf spine design that we are recommending, usually we'll see the 2700, which is 32 ports of 100 gigabit as a spine level, an aggregation level switch. As top of rack, we have two options. One is called the 2410, which is kind of a traditional top of rack, 48 ports of 10 or 25 gigabit, and 8, not 6, not 4, 8 uplinks of 100 gigabit. This is a traditional top of rack. And we have a special top of rack, which is unique in the industry, and no other vendors have it, and it's called the 2100. It's basically a half a switch. It's 16 ports of 100. All of the ports are splittable, so basically you can split all the ports by 4 and get 64 ports of 10 or 25. It's a very powerful switch because basically, and I can run into you if you want afterwards offline, you can achieve all that you are achieving here in 1U with this half a switch. Now, usually on the top of rack you need also high availability, kind of an MLAG solution. So with this solution, basically you are putting two side by side, serving the same numbers that you are serving here. Okay? Half the power, half the price, have everything. So it's a very powerful product. All the products are running Mellanox OS, which is our OS, Cumulus Linux, SnapRoute, iSonic from Microsoft. It's an open platform switch. Everything is there from day one. Our BUM, this is not kind of a technical guy, but if our sales guy was here, who's telling you basically that if you are getting our BUM, the price for, let's say for a switch, you will see two lines. Switch and support, that's it. No additional fees for features, everything, all the features are day one, from day one there. You are getting all the features there, and you can choose whatever you want. It's not locking anything.
Is this,
sure.
Is this based on your own silicon or Broadcom?
Yes, and this is our biggest advantage because this is our own silicon. And if I'm comparing apple to apples, our silicon is called Spectrum. This is a 100 gigabit silicon. The competition is basically the Tomahawk Broadcom. There is also another one called Qumran. So basically those are the two. So it's very easy for us to compare our products against other products. We are comparing the two silicons, and by that we are covering basically a long list of other vendors' products that are using the same silicon, the Broadcom silicon. Let's go back to overlay. So we said that we need to somehow do the VTAP on the top of rack sometimes when it comes to bare metal. And if Neutron is going to control that, then we need some kind of an API, right? So Neutron basically is using, we are offering a M2 mechanism driver that has the ability to, from the Neutron to control our switch over HTTP, REST API. And basically that it is. That is that. As the same way that Neutron is controlling the hypervisor, now we can control also our switch and set up the mapping between VLANs and VNIs, and we'll talk about it in a minute. Another option that I discussed is the option to do control-less. So what are the benefits of using EVPN? As I said, EVPN is basically an option to use BGP to do those overlay controls. So all the VXLAN benefits are there. It doesn't matter if it's control or control-less. When it comes to scale, better scale, again, because this is BGP. It's standard-based solution as much as possible. So no more proprietary solution. Controllers are proprietary solutions. Now there is BGP running there, so it should be standard, and it is basically. We're doing a lot of tests to make sure that we are interoperable with other vendors regarding VPN. Big advantage when it comes to interconnect data centers. There is a big challenge with the controller to do that. No spoof, better performance when it comes to bump traffic, and we'll talk about it later on. So it's a great solution. What is our recommendation when it comes to overlay? Regarding the underlay first, so our recommendation is to use, of course, leaf spine, eBGP unnumbered, which is a great feature supported today by Cumulus. It means basically that we are using the default IPv6 that are embedded already, configured by default, and we are using them. So we're basically doing 1AS for all the spines. ECMP is running between leaf and spines. So this is eBGP unnumbered, very scalable, and this is the underlay solution that we are advising here. When it comes to overlay, basically two steps, very simple, 3 commands to actually enable EVPN as an overlay technology on the leaf and on the spine. And the second step is to actually doing the mapping between a VLAN, VNI, and the loopback address that will be the channel to create the tunnel between the VTAPs. So 2 steps. One of them is enabling EVPN. The second one is to do the configuration and the bridging configuration to match VNI to VLAN. There are a few route types in EVPN. I will discuss 2 of them, which are kind of explaining how does it work. So let's say, for example, I have host A. It comes up. There is a natural learning on the top of rec about the MACs. And then what's happening is EVPN as a BGP protocol is advertising host A MACs and VLANs into other VTAPs that are sharing the same VNIs. So this is basically what EVPN is doing in route type 2. And this is actually what this operation is doing, is reducing a lot the bomb traffic, the unknown unicast and traffic. And the reason is because all the VTAPs that are part of this tunnel, this VNI, they just know each other, right? So if one wants to send a traffic to another, he knows exactly what is the path. Route type 3 means that what's happening where there is a bomb traffic, right? I'm just sending, A comes up, send traffic to an unknown host B. Okay, so now it doesn't know where exactly to go. An operation that is called Headend Replication is basically done by the silicon itself. Okay, it means it actually replicates the packets per all the VTAPs that you see that are relevant for this VNI. When I'm saying VTAPs, by the way, you can replace VTAP with top of recs. So for example, if I need to replicate this packet to, let's say I have 128 recs, it's a very heavy operation for the silicon. This is a pure silicon capability. So for example, I didn't touch the yellow boxes. Many vendors are talking about how many VXLAN they can do. Not many vendors are talking about how many VTAPs they can do, because head-end replication is a very difficult task. For example, can do 750 top of recs, while the other vendors can do 128. This is just one example. Okay. And by doing that, it's basically running the traffic to all the VTAPs on the fabric. Till now, we talked about the layer 2 aspect, and there is also layer 3. Now we're trying to make things complex. This is how the world is working. Now we're going to talk in a couple of slides about how to do routing on a VXLAN. Now think about it. We have another layer, which is routing, but we want to do layer 2. So we created VXLAN as overlay. And now someone came and said, oh, but I need to do on top of this layer 2, I need to do another routing. Okay, so this is how it's working, and we need to find a solution. So basically, it's called, there are some names for it, Riot, IRB, and so on. I'm going to call it VXLAN routing. And there are 2 ways to do it. One is called asymmetric. The other one is called symmetric. Why there are 2 options? Because each vendor decided what we want to do. We are doing both, because this is the way we can live in peace with all other vendors. And the way it works is the asymmetric way. Why it's called asymmetric? Let's say this example. We have this customer edge, but let's say server, right? Host red, which has a red VNI. And he wants to ping the blue VNI, which is in a different subnet. Okay, now this is routing. Remember, routing on top of VXLAN layer 2 overlay on top of a BGP underlay. Okay, so he wants to ping this blue VNI. So the way it works is basically there is a bridging moving from VLAN to the red VNI, and then there is routing between the red VNI to the blue VNI, going to the other side, and then there is bridging. So it's called asymmetric because the sender side is doing bridging and routing, while the receiver side is doing only the bridging. Okay? This is a simple to implement solution, but when it comes to scale, it's a bit problematic because it uses many, many routes, host routes. The other option is called symmetric. It's more scalable. And the way it works here is basically we're creating a VNI that is all purposes to do this routing. It's kind of a gateway. So this VTAP1, basically it's getting the VLAN, bridging to VNI red. Then there is routing to the yellow, then back routing to the blue, and then bridging. And this is symmetric because both sides are doing bridging and routing. Okay, this is why it's called symmetric. As I said, we're going to support both. We support symmetric today, and in October, November, we're going to support the symmetric. Very complex feature. Again, a silicon based feature. You know, if the silicon cannot do it, it will not happen. So for example, Broadcom Tomahawk cannot do it. So sometimes customers, I'm seeing the flow of customers, how they look for a solution. First of all, they are looking for a list of features that they need. So a customer needs overlay, he's looking on our products and other products and say, okay, both vendors are doing VXLAN routing, nice. Some of them are doing only 40 gig, we are doing up to 100 gig, also nice. Next phase, thank you. Next phase, it would say, okay, now let's see what is the scale, how many VTAPs you can do, how many VNIs. In the underlay, how many routes you can do. And by that, you're actually mapping a short list of vendors that actually can do whatever the customer wants. And the last step will be to see what are the special features there, usually around telemetry and so on. Okay, so I'm mentioning that because I'm saying there are some features that really are unique for Spectrum, like this one, in around 100 gigabits. We'll touch this in 2 slides. Sometimes we have actually a customer, not sometimes, that 2 customers that want to marry 2 types of clouds. One of them is based fully on EVPN, a bare metal cloud, versus an OpenStack infrastructure, which is fully virtualized, no bare metal there. We can do that. The first one was using a controller. I don't remember the name. I think it was Meternet, and a Neutron on the same OpenStack design, and on another side, EVPN. So what we can do is put actually our switches and performance gateways, short configuration there, basically static ARP and some static configuration, and then we can do this movement between those 2 sites. And this can be done also with plain Neutron as a controller. You don't need another controller for that. We're offering a kind of a package, a POC package to run overlay with all the features that we are offering. 4 switches, you can actually do with 3, but I think 4 is better because you have 2 spines, you can see better the ACMP capabilities. 4 NIC cards, everything is ours, cables and everything, and training if needed. Beside, we talked about the features themselves. Beside of that, we need tools that can do automation, orchestration, and monitoring. We have a nice tool called Neo. Basically, has 3 goals. One of them is to do monitoring. It actually provides a GUI where you see counters, heat maps, congestion points, and so on. It can provision. Cumulus or Mellanox OS doesn't care. From its perspective, you can do provisioning to the entire fabric on the leaf spine. So it's a big advantage because there are only advantages in leaf spine versus chassis. The only disadvantage is in chassis you can connect through one console and manage it as one entity. Neo is helping to achieve that also on the fabric level. And the third thing is actually integration with cloud infrastructure. So OpenStack is one of them, also VMware and Azure, but OpenStack is definitely our biggest integration program that we have with the cloud. Here are some examples. Ironic, there is a need to move from the provisioning network to the tenant network. This can be done manually, or Neo can actually listen to Neutron and actually do it automatically from Okata. This is work in progress, but we can do a scheduling. You're spawning a VM. Neo is actually recommending to Nova about other aspects when it comes to spawning a VM. For example, I want to spawn a VM only on an MLAG setup, only with high availability, or I need specific bandwidth and so on. When it comes to provisioning, especially with Cumulus, which I think, and I am a Mellanox guy, with actually developed Mellanox OS, part of the developing group. Cumulus is definitely a great solution for OpenStack as a Linux-based program. And you can use the net DevOps tools that are offered here. They're coming natively with Cumulus Linux, and this is the way to provision definitely overlay. We're touching more aspects. I didn't touch every one of them. There are a lot of things that we are doing in OpenStack community. We're very active there. Overlay is just one. For example, in Cinder, we're doing the ICER, we're doing NVMe over Fabric, we're doing RDMA. In every project almost, we are touching, and we're putting our feature inbox. So a big picture that you see is actually showing us touching in every project. Everything is coming in inboxes. This is the big power of our solution. I will finish with the use case that we have. This is a German company called Sys11, a very nice one. And basically, they are using our solution. So they are doing, they started in Mitaka with actual deployment of this OpenStack public cloud. And they are doing the 2700 in spines, 2410 in stop of racks, 25 gig to the server using ConnectX 4 and VXLAN offload and OVS offload soon. And Cumulus Linux is running their pure layer 3. This is their design, their choice. And running containers and overlay solutions. Ansible to automate, again, OpenStack public cloud running in Germany, fully with our solutions and Cumulus solutions. Thank you very much, guys. If you have any questions. Okay, so thank you very much for your time.